I'm doing a video on momentum principle. The question states: a boy of mass 60 kilograms is rescued from a hotel fire by leaping to a firefighter's net. The window from which he leaped was 8.0 meters above the net. The firefighters lower their arms as he lands in the net so that he is brought to a complete stop in a time of 0.40 seconds. For the first part of the question, it asks us to find the change in momentum during the 0.40 second interval. So the change in momentum equation is change in momentum equals mass times velocity. We know that the mass of the boy is 60 kilograms, so we have that, but we don't yet know the velocity. We later figure out that it's 12.5, but we find the 12.5 by using the work energy formula, work energy equation, which is initial kinetic plus initial potential equals final kinetic plus final potential. The final potential is 0 and the initial kinetic energy is 0, so that cancels out, leaving us with this. And multiply each side by 2 to get rid of the 1/2, and we take the square root to get rid of the squared, v squared, leaving us with v equals the square root of 2gh. So we do 2 times 9.8 times 8, which is the height that the boy jumped down, and that leads us to 12.5 meters per second. We then put that 12.5 into the the change in momentum equation, and we multiply that by 60, leaving us with 750 kilograms meters per second in the upward direction. Okay, for the second part of the question, it asks us, what is the impulse on the net due to the board during the interval? This is the formula for the impulse, but in order to find the impulse, we need to find the force. So the equation for force is change momentum over change in time. So the change in momentum was previously found to be 750. The change in time is 0.40, which leaves us with 1875 newtons. But that isn't the only force that acts on it. It's a gravitational force also. So that brings us to this equation where weight is equals to mass times g. So we do 60 times 9.8, and 60 is the mass of the boy, leaving us with 588 newtons. So we add those two together because that would be the average force, which they also want us to find, which is 2,463 newtons. And we can then plug that into this equation, which is where we got the impulse by itself by multiplying the change in time by the force. So we use that total force that we just got by adding the weight plus the force over here. So we use that, and we multiply times 0.40 because that's the change in time, and that leaves us with 985.2 newtons per second. Newtons second. Both of these answers are in a downward, should be in a downward position, like the forces are in a downward motion, because all of the boy is jumping down, so the forces would be in a downward motion.